Just before 7:30 p.m., students enter the room to find Mr. Fies dead of an apparent homicide. At 7:30, the temperature of the body is 80 degrees, while at 8 p.m. it was 75 degrees. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? For this problem, I'm going to be using Newton's law of cooling, which is the temperature of an object at time t, which equals the temperature of the room plus the temperature of the object at some given time minus the temperature of the room times e to the negative decay constant times time. My first task was to find k, which I did by creating two equations and then finding the average k between the two of them. The ambient temperature is 70 degrees Fahrenheit, which is the constant temperature of the room. The temperature of the object is 98.6 degrees because the average human temperature is 98.6 degrees Fahrenheit. The temperature of the object at time t is 80 degrees, as shown in the very first set of time and temperature. The second time, which is 8 p.m., is 0.5 hours after the initial time. So therefore, it is the temperature of an object at time t plus 0.5 hours, which is 75 degrees. I have already done the first part of the problem, which is writing down the initial temperatures equation and the final temperatures equation. Then I reduced them. Notice that here I separated the e exponents using the exponential rule, where you have a number on the outside of the parentheses and therefore you can distribute it. But since a number times a number also can equal the exponent base times the exponent base and then the two separated exponents. Now, what I need to do next is to find e to the negative kt. Then I input e equals negative kt, this one, into the one on the lower equation, therefore eliminating a variable. Now I just need to make sure that I find the k. Now to find k, I must find the natural log of both sides. And that is k. The time that elapsed. Now, since I know k, I can input it into my first equation. Now, similar to as we did above, we must take the natural log of both sides to get rid of the e. Now to find t, 0.8 hours. The time of death. In order to find the time of death, I need to take the hours I got, multiply it by 60 in order to figure out the minutes, and then subtract the number of minutes from 7:30, which was the time the body was first found. 6:42 actually, and that is the time of death. Thank you for watching, and I'll see you in class.